everyone, and thanks so much for joining me today. My name is Konstantin Maksimov, and I'm from IBM. What I want to talk with you about today is SMC-R protocol and its implementation in software-defined storage. So let's get started. Shared memory communications, or SMC, provides direct memory access through remote or internal shared memory, and it is used in addition to TCP/IP. There are two kinds of SMC. The first one is shared SMC direct memory access, or SMC-D, and it is used for the communications within the same physical server. And the second type is SMC over remote direct memory access, or SMC-R, and it is used for the communications between two different physical servers. During this session, we will focus on SMC-R only. SMC-R dynamically discovers RDMA capabilities of TCP peers and automatically sets RDMA connections up transparently to socket applications. So SMC-R allows you to use all benefits of RDMA without rewriting your application. The performance improvement is achieved by bypassing TCP/IP stack processing. The data are written directly into the memory using RDMA over converged Ethernet or RoCE adapter. The best results are achieved for streaming workloads, but you can also expect a better data throughput for request response workloads. SMC connections are initiated through TCP/IP, and after the handshake, an SMC connection is established if both sides support SMC. If not, then the connection automatically falls back to TCP. And there is one limitation. SMC supports TCP only, and UDP is not supported. SMC-R protocol implementation is 100% open source. So an RFC publication is available at rfceditor.org, and SMC-R source code is a part of Linux repository and located at git.kernel.org in net/SMC directory. And NetDev mailing list is also available, so everyone can see what's going on and participate in discussions. There are two ways to enable SMC in your application. The first one allows you to use SMC for existing application without recompiling them by using an SMC preload library from SMC Tools open source package. The library intercepts existing application socket calls and dynamically replaces TCP with SMC. And the second approach involves changing the first parameter in socket calls from AFNet to AF-SMC and recompiling the application. SMC Tools package provides commands that help you to manage SMC connections. You can download it from GitHub or install from distros. I want to describe the most important SMC Tools commands. So existing TCP/IP applications can use SMC without recompiling if they are started with SMC preload library. You can do it either using SMC run script or LD preload environment variable with your application start command. The next command is SMC-SS, and it is used to display information about the active SMC sockets. And its main page contains error codes and error descriptions. SMC-R stats command displays statistics about SMC-R, such as number of total connections, number of SMC-R connections, number of TCP fallbacks, and read-write buffers information, such as buffer sizes and buffer full errors. SMC check command makes sure that connections are using SMC protocol. It runs a connectivity tests and displays SMC type, D or R, in case of success, and the error if the test fails or if the connection falls back to TCP. SMC check server is started on the remote host, and then we run an SMC client connection to the server. On the right-hand side, you can see an example of a successful SMC-R connection and another example of a connection that has fallen back to TCP. To configure SMC-R in Linux, you need to verify the availability of Rocky adapter. Then you need to make sure that SMC tools package is installed. The next step involves installing custom Linux policies for SMC socket. The reason for that is that standard distros policies do not include SMC sockets. And finally, we need to increase the read-write buffer sizes in Linux. So now we come to the next point, which is software-defined storage, or SDS. It is a software program that manages data storage resources with no dependencies on the underlying storage hardware. It can be run on any industry standard system, and no proprietary hardware is required. Currently, I work on one of SDS implementations, which is called IBM Storage Scale, a clustered file system that provides concurrent access to data from multiple nodes. The cluster can be configured in various ways, and on this slide, you can see an example of a configuration that is often used in large clusters, network shared disk client-server configuration. In this configuration, some nodes are defined as servers, and they have direct access to disks, and other nodes are defined as client, and they communicate with the server nodes over the network, which is extensively used for each read-write requests from client nodes. Therefore, we need a very fast and low latency network, and here SMC-R protocol comes into play and helps us to improve the network performance. Now let's have a look at SMC-R implementation details in IBM Storage Scale on Linux on Z platform. Last year, we have already implemented SMC-D protocol support, and now we are working on SMC-R implementation, which is not ready yet. In C++ code, we are changing socket calls and replacing AF-SMC to AF-inet to AF-SMC. And in Python code, we use different SMC tools package commands to verify the SMC-R requirements and to monitor SMC-R events and SMC-R connections in the cluster. So now I want to mention one potential performance bottleneck that may cause in SMC-R to perform even slower than TCP in some cases. So actually the fix has already been provided, but the patch hasn't been accepted yet. This performance bottleneck in upstream SMC-R implementations can happen only in the environments with a very large number of SMC-R connections, and I haven't seen it in our environment. The default TCP sockets buffer sizes in Linux are way too small for SMC. And in order to get the best SMC-R performance, I recommend increasing the default and maximum buffer sizes to 512 kilobytes. You can check the actual buffer sizes using SMC-R state commands. You can increase buffer sizes using sysctl command, or as an alternative, you can use SMC-R, SMC-run script and its parameters to set buffer sizes. And some applications can override default buffer sizes, and in this case, you need to configure the buffer sizes within your application. Now let's move to the next part, which is SMC-R hardware I'm using for the development. I have 3 LPARs on IBM Z16 server, 2 Rocky adapters with 100 gigabit ports, and a switch with 100 gigabit ports. Rocky adapters are connected to LPARs and to the switch. And on this diagram, you can see the network performance management using iPerf3 tool for TCP, the first row, and for SMC-R, the second row. SMC-R performance heavily depends on buffer sizes and number of parallel streams. With the default buffer size is 128 and 1 stream, the performance is even worse than TCP. But if you increase the buffer size to 512, then we get a much better number, 34 gigabits per second. And if we, in addition to that, use several parallel streams, then the speed becomes 74 gigabits per second, which is 3 times faster than TCP. And as you can see, these 2 parameters don't have any impact on TCP performance, which is always the same. Well, that brings me to the end of my presentation, in which we have covered SMC protocol and software-defined storage topics. I hope you found it useful. Thank you for your attention. If you have any questions, I'm happy to answer them. For SMC, it's for SMC-R, yeah, iPerf3 tool has how we got this number for SMC-R. The question was how I got how many streams I used and how I received this number. So for TCP, I also in the last column I use 4 streams and buffer size 512, and it did not have any impact on the performance, at least using iPerf3 tool. And the performance improvement was only for SMC-R when I increased the number of streams and buffer size. Yes, exactly the same environment, the same network. And we are waiting for the next IBM Z hardware, Z17, where 100 gigabit ports will be a standard hardware. This is non-standard setup. Therefore, we are not officially support SMC-R because customers cannot use this hardware yet, but Z17 has been released, and our test team will return to the testing. Okay. We are out of time. Thank you very much.